Okay, excellent. In the interest of time, I'll get started. So welcome everyone to this IES forum on climate change and the marine environment. We are delighted today to be joined by three expert speakers who I'll introduce before each of their talks. Just before that, I'll go through some quick housekeeping. So after all of the presentations today, you will have the opportunity to ask questions. So please do submit these in the Q&A option at the bottom of your screen at any point during the presentations, and I will then read these out on your behalf later on. If you want to pose questions to a particular speaker today, please do put their name in the question and feel free to put those questions in at any point. Thank you so much for logging in today. I'm now going to introduce our first speaker. So I'm delighted to be joined by Dr. Katy Hill. Katy has over 20 years of professional experience in marine and climate science, working at national, international and intergovernmental levels, particularly focusing on the science to policy interface and the case for investment in sustained ocean observations, data and prediction infrastructure. Katy is the UK G7 Marine Science Coordinator and co-leads the G7 Future for Seas and Oceans Initiative Coordination Centre. Thanks very much for joining, Katy. Over to you.
Thank you. Let me just start by sharing my screen. All right, so my name's Katy Hill, and I'm really going to take that global view and recognizing that some of our and making the case for needing to understand the view the ocean is highly connected. Can everybody see all right? Okay, I'll just keep going. One reason of this is this kind of highly connected circulation system that connects our ocean basins and the surface ocean to the deep ocean. And what we notice is these polar processes in particular have increasing importance on our climate. And as I said, those changes that we see in those regions then connect and impact the whole ocean and our weather and climate. So this highlights the change that we're seeing in annual temperature across the globe. So this is that spatial representation of that temperature change due to anthropogenic forcing. And what you can see is that major increased impact on the polar regions. But also these temperature changes would be much bigger, of course, if we didn't have an ocean. The vast majority of heat being taken up by the climate system is going into the ocean, more than 90%. And this shows the tracking of the upper ocean heat content, 0 to 700 meters, and then down to 2,000 meters. Half the ocean sits below 2,000 meters. We don't have the systematic observations in place to plot that on this graph. With confidence, we are getting there with new technologies, but that just shows the importance of systematic observations. And of course, because of our increasing ability to measure the ocean, we've seen the ocean component of the climate system be more represented increasingly in IPCC reports, the nature of the changes we're seeing in the ocean and the impacts that has both on ocean systems, but also more broadly on our climate. In particular, there was a recent special report on ocean cryosphere and a changing climate. And I just want to acknowledge liaising with Mike Meredith, who was one of the lead authors of that report and is very involved in the IPCC. He's from Bath, who helped with some lovely slides. So as I said, what happens in regions doesn't stay in regions, and the Arctic is a big indicator of that. So we're seeing alarming changes in sea ice in the Arctic region, and alarming temperature trends in that Arctic region, which means that we are likely to reach an ice-free status at least in one summer by 2050. Now that, of course, has detrimental impacts on Arctic ecosystems. We've all seen pictures of starving polar bears, but also has impacts on that connected circulation system that we saw. The other thing that's increasingly talked about are marine heat waves. So this is where you get periods of intensified heat on top of that background change. And that is seen in particular regions in relation to kind of changes in variability in circulation, which amplify that background signal. It has huge impacts on ecosystems, particularly movable species can shift their ranges, but unmovable species or species that move more slowly, such as benthic ecosystems, coral reefs, can they respond and adapt to that variability and long-term change in time. And certainly I used to work in Australia, in Tasmania, working on the East Australian current. That signal you see down the east coast of Australia was a hot topic in terms of major shifts in the ecosystems in Tasmania due to invasive species and detrimentally impacts on those ecosystems, which had no shelf zone further to go to the south, the kind of giant kelp forests and the rock lobster fisheries and things of that sort. Another one, of course, is ocean acidification. As the ocean, the CO2 in the atmosphere increases, about 25 to 30% of that CO2 is absorbed into the ocean, which changes the pH of the ocean. That then has impacts in species, organisms which are not able to form their shells from calcium carbonate. And you can see again that is a bigger issue in the polar regions, but is also a double whammy in, for instance, coral reefs, which are very sensitive to this. It's another stressor in addition to heat and bleaching. So it's something that we do need to be aware of, as the ocean's doing us this favor of buffering what we pump into the atmosphere. Okay, number 3 is ocean deoxygenation. And sorry, I couldn't get a better slide for this. I will try. So as the ocean is warming, it makes the surface ocean less dense relative to the deeper ocean. And it means that the ocean kind of stratifies, kind of stabilizes in layers, and it's harder to mix across those layers, which means that mixing means that the water that's been in contact with the atmosphere doesn't refresh those deeper layers so much, but also a warmer water holds less oxygen, right? So in combination, it means that we're seeing a reduction in oxygen levels in the ocean, and these kind of deep oxygen minima, and in combination with issues around river outflows and dead zones, it's a real concern for the ocean. So those 3 areas are your triple whammy. Of course, the loss of ice and the increase in temperatures in the ocean also mean that we get thermal expansion and sea level rise. But it was those big picture issues, the heat, the acidification and the deoxygenation I wanted to point to. And the next talk will talk more about what that means in the context of the UK. And of course, these changes need to be seen in the context of broader shifts and threats to the ocean that we need to understand. And this is a nice diagram highlighting that it's not just climate. We're talking about multi-stressors and multiple impacts. Some of those that we can control, some of those we can minimize, and some of those that we can't. So we do need to work towards a more kind of active and adaptive management of our ocean systems. All right, so I'll move on to observations. And of course, there are kind of global agreements on measuring what needs to be measured to track our climate. And the Global Climate Observing System is one that sets requirements for essential climate variables. And another picture of that is listed here. So a small number of ones that are agreed as priority, and they write implementation plans and progress reports, which get submitted to the UNFCCC Conference of the Parties, such as the one coming up. And I previously wrote coordinated the ocean section of a previous plan. Now, what do we need to in terms of gear in the water or satellites to measure these? Well, we've oh, sorry, I should have said those are the things, the key things that we need to measure. Of course, historically, changes in the climate have been focused on those on surface temperature, but we know that doesn't tell the whole story and can be misleading. So we did work then to develop global climate indicators. So that is a small number of indicators which have clear trends or signals which we can use to describe in a kind of holistic and complete way how the climate is changing. And this is now the basis of the kind of global state of the climate report, which is also presented. A preview of 2022 will be presented at COP. And a number of other reports locally use this framework. So observing the ocean. So this is my passion. So the top left and top right pictures feature me. You can see if you can see my purple hat. So this is just an example of some of the ways, you know, to be able to present those lovely pictures, we actually need people to go out to sea on ships and deploy gear and increasingly deploy drones and robots in the ocean. So it's a very exciting space and still an opportunity to get our hands dirty. But historically, we have quite a relatively thin slice of observations. We've just celebrated the 150th anniversary of the first ever oceanographic expedition, and actually a colleague wrote a paper comparing the Challenger expedition and the Gazelle expedition, which is a lesser known German expedition, with the present day observations, which is very, very exciting. But you can see that our coverage has been relatively sparse, particularly in the southern hemisphere and polar oceans, but because of our autonomous technology, that is changing. This is roughly what the observing system looks like today in terms of in situ observations, which is quite complicated, but you can see a long list of things down the side. And I'm happy to provide more detail. One of those examples which has really revolutionized our understanding and means that the ocean is that much more visible in the last two IPCC reports is a huge bedrock foundation of our climate prediction capability, is the International Argo program of profiling floats. So these floats profile the ocean and beam the data off to satellites and drift around. And it's this fantastic international collaboration. And building on that, we've got more and more robots for targeted activities, but this is the first time that we have that global scale, broad scale subsurface observation of the ocean that complements that. And this just highlights some of the other platforms. So I give an example of gliders down there, of Argo floats, and also a glider down there with a colleague swimming with it in the Solomon Sea, as kind of the glider is almost an evolution of that Argo technology that porpoises through the water, and you can talk to it and change its direction. The animal tagging, the seal tagging, is something that's revolutionized our ability to see changes in the polar oceans and under the ice, because they dive around the areas that we can't, and they're almost a thinking Argo float, if you like. But of course, a lot of that data is also used to understand their behavior and their feeding patterns and stuff. We also have increasingly autonomous surface vessels, which will be critical because they can give us that high density surface data. So you've got sail drone, the orange one in the top, and wave glider, which is moves by wave propulsion. And increasingly looking at evolution of moorings, recognizing that while they're being in part replaced by some of this autonomous gear, moorings still have an important role with things like sensor packages, which can move up and down the line rather than having multiple packs of sensors up a mooring array. But that graph is really critical in just highlighting how, we've just seen an explosion of the available data in relatively recent times, only really since 2000. But that new systematic data really enables us to shine the light on that sparser historical data and create new insights from that. So just in conclusion, I just wanted to highlight, I've gone a bit faster through those than I thought, but the ocean is one highly connected system. So the local changes that we might see, for instance, in the Arctic, don't stay in the Arctic. And ocean observations are critical for tracking climate change and climate impacts, and have given new insights into the role of the ocean in the climate system, as seen in the last two IPCC reports. And that those new insights that have been enabled by that explosion in technical capability to measure the remote ocean in particular. From my perspective, challenges are placing the ocean at the heart of climate policy and decision making. Ocean issues are broadly relevant across a range of issues, but not front and center priority often. So I work with government quite a lot, and in the run up to COP, we got, we know the ocean is important, but we want to talk about the things of direct relevance to climate policy. Whereas a lot of us feel that the information from the ocean will give you that foresight, the predictive capability, and hence that foresight to make good policy decisions. So that's still an uphill battle, but there was a strong push to get oceans integrated into the COP26 outcomes, into the Glasgow Compact, and hence, and one of those agreements was to have an ocean dialogue every year in the scientific and technical meeting in the run up to COP, but also a commitment to strengthen and integrate ocean issues across the COP agenda. How that will be done will be interesting, but I will be at COP27. There will be an ocean pavilion. So if anybody is there, wants to learn more about oceans and climate, come find us at the Ocean Pavilion in the Blue Zone. We also have an issue where, well, that map I showed is really impressive in terms of the amount of gear in the water. Of course, some of those things just, the observations are not as big as those dots, and there are still big gaps. Some of those observations are only on the surface. Some of them only do a shallow, have a shallow footprint. We're still really reliant on research projects to fund most of that observing system. So I really call it held together with duct tape and determination. We're reliant on single, often named individuals to doggedly champion the funding of those observations, and it's largely a positive side effect of research programs. So it's a phenomenal achievement in that light, but many of those stubborn colleagues that we know and love are now starting to retire, and I'm not sure that we can run a system like this, particularly as we talk about expanding it into new variables and new communities for another 20-30 years. We really need to consider sustained funding, and funding it as a form of infrastructure, if you like, at the global level, so that we have that fit for purpose investment, not just putting in the gear in the water, but running it, delivering and managing the data in a form that's used and usable. And then, of course, as we expand into chemistry, so some of those new platforms that we talked about can increasingly carry chemical sensors to give us more systematic observations of things like ocean carbon in uptake and the processes which govern that, and the oxygen changes and things like that. But also, how do we track changes in ocean ecosystems and ocean health? That's an even bigger challenge. But of course, biomolecular approaches and eDNA are showing real promise in helping to provide that more holistic view of changes in ocean health. So I will leave it there, and hopefully that's given you a bit of a snapshot of the world, the global ocean world.
Thank you so much, Katy. That was a really interesting presentation about the importance of ocean observation. And any of our attendees, please do put questions for Katy in the Q&A function, and we'll come to those at the end of all the presentations. Thanks, Katy, for that. I'll now introduce our next speaker, Paul Buckley. Paul is a principal scientist based at the Centre for the Environment, Fisheries and Aquaculture Science. He is the Programme Manager for the UK Marine Climate Change Impacts Partnership, which I believe he's going to talk a bit more about. So thanks very much for joining us. Over to you.
That's right.
Stop sharing your screen and then Paul can share his.
Perfect, thank you. Okay, so hopefully you can see my slides now. Can someone confirm that you can?
Yes, all good. Thank you.
Okay, yeah, so my talk today is going to be nearly 20 years of the Marine Climate Change Impacts Partnership in nearly 20 minutes. So hopefully I'll try and stick to that. So just to give you a bit of background to the partnership itself. So we came together back in 2005. It was off the back of a UK State of the Seas report called Charting Progress, if anyone can remember back to that coming out. And there's a kind of realization as part of that process that there was a growing body of evidence at that time on marine and coastal climate change issues, but no one was really kind of working to collate that and principally that time thinking about how we translate that in a way that's meaningful for a policy audience. So that was really how we kind of grew out of it, and kind of providing that overview of the state of the science in the UK has always been our kind of core offer of what we've done. So we started back in 2006 when we produced our first report card, and ever since that we've been producing periodic updates on those things, and it's trying to look across I guess the whole range of issues that we want to consider, from some of the change in the physical environment, which Katy would have talked about before, so those issues around things like sea level rise, sea temperature, acidification, and more recently things like deoxygenation are featuring there. On the ecosystem change side, looking across a wide range of coastal marine habitats and species, and then thinking more broadly about how some of those impacts are starting to affect society, and I guess particularly in the marine space. We might be thinking about things like fisheries and aquaculture, but also things like coastal and marine infrastructure and what effects we're seeing there. So over time, as the partnership's matured, then I guess we've expanded some of the stuff that we've done on top of that core offer. So we've done a lot more work on kind of what we're calling building solutions on that side of things. So think about resilience and adaptation, particularly working with different trade associations in the UK. And most recently, we started to dip our toe in terms of doing some work overseas as well. And I'll talk a bit more about that later on. So yeah, so really it's MCCIP is there to try and provide that coordinating framework in the UK. We engage really widely with the scientific community. We've got those links directly into the policy side of things as well. And I think over time we're trying to reach out to more and more stakeholder networks. So it's really good to have the opportunity to speak here today as well. So just to kind of clarify in terms of our core partnership, it's largely driven by UK and devolved government and their agencies, with a bit of scientific institutions built in there, particularly people like the Met Office on it, but really that's just the conduit to kind of reach out to a much wider audience as well. So in terms of the work that we do, then I think that core to what we do, particularly in terms of the evidence reporting, is trying to make sure that we maintain this idea of kind of integrity and independence. Is something that we really strongly believe in terms of what we do. We wrote about it a few years back when we were doing our 10 years experience of reports on that side, to try and share the lessons that we'd learned in terms of how the evidence base was growing and what that was telling us, and the challenges that presented within itself, and how best we get that message across the different end user communities. So I think for others that are kind of going across that kind of path as well, then we kind of laid out this 4-step process in terms of what we do. So thinking about the information that we're interested in, it'd be easy to focus on a few specific issues. We might naturally drawn towards things like coastal flooding at the coast, or fisheries and the marine environment, but it's trying to take that broader view and that broader interest. So we've always tried to look across a very wide range of topics in terms of things that we focus on, and making sure that agenda is set, I guess, not just by ourselves in the steering group, but trying to reach out to stakeholders, and in particular being led a bit by what the scientists are telling us as well. Again, once we've decided what the information is that we want, this kind of idea of what the experts that we're going to use, trying to get that broad base, so it's not just a very narrow, perhaps government-led view in terms of the science itself, is trying to be as open as possible around that. One of the things we tried to institute a bit more recently is having an expression of interest in terms of people becoming authors, contributors. So trying to make sure that we really provide that quality assurance of the science, that we're taking in that breadth of views. And there are a lot of competing views out there. We need to make sure that they're all fully captured and then thoroughly independently peer reviewed as well. On top of that, then getting the information in, I think taking the time is really important. I think these things can be rushed. Once you've got that evidence in, it's making sure that we get that information out in a sensible way, having that clear terms of reference, in terms of how we represent those different views, and making sure that we always go back to the scientists, like Katy and other people like that, making sure that they're happy with the way that we're translating that evidence for end users. And then finally, making sure that we can give an idea of the level of our understanding about things. We've had confidence assessments for a long time, building on things like the IPCC type approach, but we always try and put that into the work. So hopefully, if you kind of use the evidence that we're looking at, you can be fairly confident it's coming from a good source. So I mentioned a bit more in terms of looking at solutions, and that's something I guess we need to think more about in a UK perspective, not just laying out that evidence base. We've done some previous work with the marine leisure industry before. They're particularly interested in how climate change might affect the seasonality of their industry, and how particularly things like extreme events might affect integrity of ports and harbours and boats and ships themselves. After that, we did a much more detailed report with CEFAS. Then as part of the first round of the climate change risk assessment and NAP process, then one of the things came out of it was the government really wanted to know how the seafood industry was preparing for climate change and how it's looking to respond. So we teamed up with CEFAS on that side. So they've done a piece of work now looking at wild capture fisheries in the UK, both in terms of the domestic system, what's going to happen to the catch itself, and what's going to happen to the way we go out and catch and the supporting infrastructure, but also looking more broadly at the kind of supply chain issues, not just within the UK itself, but looking at changing patterns of potentially imports and exports in the future. So if that's something you're interested in, then I'd certainly point you in the direction of that piece of work. And then also thinking about climate change from a conservation perspective, then there's a whole range of legislation, obligations that we're signed up to, that particularly around marine protected areas, and we need to think about how climate change is going to affect that. I think there's been a degree of reticence. In the past, there's been a focus on trying to get those marine protected areas defined, and the whole idea of climate change having some effect on that, has kind of muddied the water a bit. And I think now we're at a stage where we really need to be trying to move that discussion forward. And I think we're going to hear a bit more about that kind of stuff in one of the later talks. So from that perspective, we've really tried to focus on how climate change is going to affect particular features of conservation importance. So in terms of habitats, that might be seagrass, things like salt marsh as well, and thinking about how, when we're planning, how do we make changes that could take account of climate change in the future. So I think the role that we play within that is try to bring together different bodies, different disciplines, those wider networks, to identify those key needs around it, try to create some new networks, placing some of those different people together, and making sure we come up with kind of tools and resources that are relevant to the different end users, from very high level summaries to more detailed information behind it. So I guess in terms of how things evolved over time, I think whether that be for us or for other people as well, looking at marine climate change impacts, I think there's been, an increasing realization of looking at things on different types of timescale. When I kind of go back to that kind of 2005-6 period when we were starting out, there's very much a focus on thinking about the limited projections that we might have out to end of century. But I think over time, there has been an increasing need and indeed an increasing capability in terms of coming up with shorter timescale predictability, as well as some of those longer time projections. So this is really just a very crude summary of some of the things that we might be interested in, those different timescales, from those impacts of weather, looking at changes on the course of a few hours, which perhaps we'd be less interested in, but increasingly thinking about how changes in seasonal, subdecadal, decadal changes as well, and the predictability that we've got around that in particularly North Atlantic waters might affect how we understand changes in things like fish stocks, how that might be built into some of the planning cycles, some of the reporting that's needed under things like OSPAR as well, looking back a few years and a few years ahead into the future rather than much beyond that in some cases. And then looking at the infrastructure side of things, then in the ocean, it might be anything from that multi-decadal timescale, but all the way through to anything up to a couple of 100 years if we're thinking about the nuclear industry. So I know that when we're working with those kind of bodies as well, they want to look at things on those kind of timeframes. So the 2100, isn't a barrier anymore. We need to go beyond that to think about those lifetime of the operations there. And beyond that, within something like the nuclear industry, knowing how well it needs to be protected, then there's a need to understand things like the 1 in 10,000 year event and how that is likely to change in a changing climate as well. So pretty challenging to go out to those kind of timeframes and thinking about those high magnitude events, but it's something that we need to increasingly do. So in terms of the work that we did, then I think it's really about trying to feed into principally into things like the Climate Change Act, so the Climate Change Risk Assessment, which we're now in the third iteration of, the NAPs and the RPs. And I think as those things have developed over time, and I think Katy was alluding to some of this earlier as well, there is an increasing representation of the marine environment within there, which is really positive. But I think it's still fair to say that compared to some of the land-based issues, it is a little bit marginalized, and we have to keep beating down the door to make sure that it's captured. And I think it's probably exemplified in terms of some of the risks that come out of something like the CCRA. They're very broad if you look around the marine issues. We're talking about marine habitats in general and things like that. We're not really getting down to the individual changes that we might need to look at. So I think we're getting there, but there's certainly more work to be done. So all that kind of work feeds into the various national adaptation programs, whether that's at the England and Wales or the Scotland level. And there's been a number of, we're aware of the adaptation reporting powers that are part of the Climate Change Act. So this is where particular organisations need to report on the risks and respond to them. So there's been quite a few around the marine side as well. But again, it's a lot more limited than some of the stuff we've had in the land-based aspects. Also feeds into the state of seas reporting, it's what we came out of. Think about MCCIP, but I think for us then it's as important to try and help the research community demonstrate the impact from their work and bring them together, particularly with those policy leads to make sure that they're talking to each other. That's probably, I guess, the most important role that we can have, and making sure that we can help others adopt similar approaches as well. So in terms of looking at things as a whole over that period of time, we did a piece of work earlier this year, that culminated earlier this year, looking at key challenge and emerging issues from across that piece, across the 26 topics that we looked at in 2020. Then we asked the lead authors around that to think about what are those key challenges, emerging issues that you have for your topics. So when we tried to pull all that together, there was well over 100. They were pretty detailed, so we needed to find a way of really summarizing that down and thinking about how the whole thing kind of fit together, from those evidence providers all the way through to people that are using it at the end. So this is really the way that we decided to organize that, seeing that continuum from the left through to the right on this screen. So how do we help people like Katy and others to develop their monitoring programs, knowing that there are still big gaps that we need to deal with to tell us anything about long-term climate change? How does then that filter through to those people that are looking at ecosystem level impacts and ultimately societal change? And then how do we use that to help us implement various bits of legislation and start to value some of the assets that we've got in the marine environment? So just to highlight a few points that came out from here, and this ties in quite nicely to the talk that we had earlier. These are just a few of the key challenges that came out from across those different topic areas that we looked at. So one of the ones that came out quite strongly on building the evidence-based side was the issue of marine heat waves, which has already been introduced. So globally got a lot of attention, and particularly around the Australian areas that were talked about before, but also more work being done in the UK now, and trying to tie both heat waves and cold snaps as well to impacts on marine ecosystem change. So the piece of work done recently in CEFAS, my host institute, where links are being made between both the hot spells and cold spells, and thinking about fisheries captures in kind of lagged effects in 5-year kind of timeframes. And there seemed to be a good association between some of the hot spells and increased catches of lobster and sole, and also cold spells and more limited catches of crabs in the future. So there seems to be positive and negative effects, and that we started to kind of scratch the surface around that, but trying to understand a bit more about what that means for marine ecosystems, and dare I say marine ecosystem services around the coast. There needs to be a lot more work to be done there, and something we need to focus on. In that kind of middle box, that ecosystem change and societal impacts, then something that keeps going back time and time again when we're trying to do evidence reporting is a lack of information around coastal communities and their health and well-being. So there's been pockets of work done in the past, particularly about a decade ago, there was work done around social deprivation in the context of climate change and deprived coastal communities, but really not a big effort to bring this all together. There's a bit more work going on at the moment, thinking about mental health aspects, both in England and Wales, thinking about how coastal flooding might affect those kind of things, but it needs to be a bigger picture done to draw some of these issues together. We know there are potential issues in coastal areas around people's health that are related to climate change, but it's not been really explored in any great detail. Then finally, on that kind of supporting decision-making obligation side of things, then certainly from a climate change perspective, there's big gaps in terms of quantifying what climate change risk means sectors. And as a case in point, then something like tourism and marine and coastal recreation, we know they're pretty high value activities. We know there's a lot of people that are participate in that on a day-to-day or longer basis, but really we don't have very good climate change assessments to make any good judgments about what we might want to do in the future. So I guess it's not just things from the UK perspective. As I mentioned before, one of the more recent things that we've done is this work in the UK overseas territories. So we engage pretty widely with territories themselves, people that are working, scientists, and the various other people that are working in the UK to administer some of the remote territories out there. And through various workshops and research that was done by the scientists working in the area, we kind of looked at those 14 very diverse, very spread out overseas territories that the UK has, and focused down in these kind of 6 regional areas. And in terms of the priority areas, that you can see them here, there's some similarities across those different areas, but certainly it seemed like there were issues that related to kind of local scale aspects, whether that was habitat change, particularly coral species in warmer areas, and in some other areas, things like kelp forests. Then thinking about things like food security, local scale fisheries in some areas was certainly important, but also where some of those outposts are a little bit more remote, what's going to happen in terms of climate change, in terms of importing goods and particularly food where it's needed, and it's certainly a long way from anywhere else. On that kind of broader scale, then, given that quite a lot of these territories sit in pretty broad ocean basins, there's a lot of interest in terms of what was going on in the wider marine environment, thinking about ecosystem functioning, food web dynamics, larger scale fisheries as well. And certainly in the semi-enclosed basin of the Mediterranean, there's a lot of interest in non-native species. The overseas territories there are pretty well apart. They're pretty much in the eastern part and the western part in terms of what we've got with the Gibraltar and the sovereign states then. But for both of those aspects, then non-native species came through pretty strongly on that side. And then trying to bring that all together, again, I guess going back to some of the pictures that Katy was showing right at the beginning, that connectivity of the wider ocean, then certainly a lot of concern about what changes might mean for things like carbon cycling, both physical and biological uptake of carbon and release, and what Antarctic melt might mean for the global system. So across those really interesting, diverse overseas territories, there's some pretty big issues that they want to look into in a lot more detail. But at the local scale, I think there is work happening, but I think there is a continued need for us to help try and support with some of the evidence that we can provide as well. So in terms of meeting those challenges, then I think going back to the kind of principles that we talked about before, we would always look to try and do it through integration, bringing different disciplines together, having the evidence in that line of sight, making sure to communicate responsibly, and helping to support some of the better outcomes from it. So just to flag a couple of bits of work that are coming up on that side, then around that coastal communities health and well-being piece, then we're starting to try and think about how the different pieces of those communities fit together, whether that's public health bodies, coastal partnerships, local communities themselves, and the research community, trying to bring them together and trying to define the issues, really, because even that stage of things hasn't really been done before we start thinking about what the responses might be. So our intention is to do some systems mapping, which kind of builds on the kind of work that we're doing in the last climate change risk assessment, looking at the range of climate drivers of interest in the coastal and marine environment, thinking about the impacts that's having, the interactions between them, and what are the interventions that we could have in the future. So we're looking to take that forward over the next 12, 18 months, really. And then on the UK Overseas Territories side, having done that look across the piece, what are the priority issues that have been identified? They're thinking about how we move that into actions. Is there more that we can do, both from the evidence that we generate in the UK? I think there probably is, in terms of some of the smaller scale ocean projections that we can use in these regions, but also looking at some of those local scale issues that they've identified around things like fishing security and stuff like that, and working on the ground with those people. So again, that's something we're looking to take forward in the near future. So just a quick update of things you might be interested in that's going to be coming out in the nearish future. Then in terms of providing the evidence, we're moving from this periodic publications of evidence to a rolling update model. So we'll still produce detailed reviews that are peer reviewed as well, and some summaries, but trying to speed up the way in which we can update that information over time. So what you can see on the screen here is the full range of topics that we'll be looking at. And in terms of presenting some of the evidence from those topic areas, then we'll be starting to run quarterly webinar series. It will be, first ones will be around acidification, aquaculture, and coastal flooding. So if you're interested in learning about those from the lead authors there, then please do join us on the 1st of December, and I can send around those details. And then just finally, just a quick overview of the resources that are available. So we've got the evidence reviews, the key challenging emerging issues bits that I talked about before, and the principles that we would suggest are needed to take forward those key challenging emerging issues. The solutions work that I touched upon earlier. In between that, we've done some work on special topics. So if you're interested in how ecosystems kind of come together in a climate change sense, fishery and aquaculture, marine biodiversity legislation and implications of climate change for that, and some of the learnings for communication, then those right there as well. Some journal papers that have come out of it, and then most recently those climate change assessments from the UK Overseas Territories that we've written up as these regional online cards. So hopefully something there for everyone to go into. I know it's high level interview of the kind of things that we do rather than the detail of some of the impacts itself, but I would certainly encourage you to come and join some of our webinars and have a look around the site for the things that are of interest to you. So just to finish, the usual contact stuff. So thank you.
Thanks very much for that, Paul. Really great to hear about how you've been working to bring disciplines together in this important area. The IES is really supportive of the kind of systems approach, so really interesting to hear about that. Thank you.